Hello, this is Dibyabrata, and I'm doing a presentation on slope fields. I'm in AP Calculus, and this is period 2 for art. First, we're going to define a slope field. This is the online definition from Wikipedia, and it states, in mathematics, a slope field, it's also called a direction field, is a graphical representation of the solutions of a first-order differential equation. And we'll show you what that exactly means in the future. And then our book, Calculus Early Transcendentals, describes what it is used for. It says, unfortunately, it's impossible to solve most differential equations in the sense of obtaining an explicit formula for the solution. In this section, we show that, despite the absence of an explicit solution, we can still learn a lot about the solution through a graphical approach, direction fields, or a numerical approach, Euler's method. We won't be paying attention to Euler's method, so let's move on. Here we have a sample problem. It says, sketch the slope field for the following differential equation. It says y prime equals xy. They might even phrase it dy over dx equals xy, or any other terms, I guess. So what you might do is first start out with a chart, okay? So we can have x, y, and f prime of x equals. And then, I'm sorry for my handwriting. And you will just chart out the values, and then the third value, f prime of x, is the slope of the small dash you will draw on your slope field chart. And so let's move forward, and those are your values. And at these points you have a slope of 0 because that's the solution to the equation. Then you have a slope of 1 here, and a slope of 2 here, and a slope of 3 here. It's just a rough sketch. And then you have zeros all through here, and you have a negative of these, and then so it's basically the opposite. And sorry for that. That's fine. And another part of the problem would be sketch the solution through point 0, 1. Okay, so we'll have point 0, 1. And you'll have a parabolic function going through here. So that's the main crux of this slope field type problem. Okay, and then you might have to go into more detail, but for the most part in AP exams, this is the type of graph that you'll have to do. Next part. Okay, so here we have a slope field, okay? And we have 4 differential equations that might match. One of these matches the graph, okay? So our task here is to find which differential equation matches the graph. So first we start off with matching points, I guess. So we can start off with point 1, 1 on the graph, okay? So when we test it, we get y prime of function 1 is equal to 0, which matches the graph, so that's a check. And then we can check the next one, so it's 2. That does not match the graph, so we can cross out this equation at that point. And then we have the third equation, and it is 0, so we have 2 valid equations so far. And then we go on to the next one, and we have 2x minus y at point 1, 1. So we have a 1 slope. That is not matching the graph, so we can cross this one out as well. We can go to another point now to finish off the problem. So let's go 2, 0. Alright? At this point, we have, looks like on the graph, a slope of about 4 or 5. So we can test it. At the first equation, we have a slope of negative 4. So that does not match the graph. So we can basically cross it off. And if you want to do process of elimination, you could. But we're gonna go on and finish off the problem because you don't want to make mistakes. So when we test this value at equation 3, we get a slope of 4. This matches the graph visually. So we can determine that the equation is x squared minus y squared. So yeah, and then if you want to like test the make it quicker on yourself to eliminate these two equations, you can see that at points where the x and y value equal each other, the slope is 0. So you can just cross out any function that doesn't match these parameters. Okay, moving on. Okay, this is our third example. This is the 2006 AP Calculus AB free response question. Before I do this for you, you can pause the video and try to do the same thing yourself. Okay, now that if you're back, then let's start doing this. Okay, at x equals 0, we won't have any slopes because it's undefined. And then at all the others, we have a slope. Okay, so at x equals -1, y equals -1, we will always have a 0 slope, except when x equals 0. And then at x equals 1 and y equals 0, we have a 1 slope. And then at x equals 2, we have, and y equals 0, we have a 2 slope. Actually, that's a half slope, my bad. And at 1, 1, we have a 2 slope. Please forgive that. And we have the exact opposite on the other side. We have a -1, then we have a -1/2, and we have a 2 slope. A -2 slope, I'm sorry. So that's the extent of what you're gonna get in a slope field problem. And then below you have a differential equation problem where you're given an initial condition, and you have to find the y equals of it. I detailed the steps to it if you want to pay attention to that. And on the next one, we'll have tips to finishing these problems, and I'll also include additional resources where you can find AP Calculus AB problems with slope fields. A tip for completing AP Calculus slope field problems is to look for patterns. One tip is to look for functions where there are only one variable. There will be patterns, like in the function y/4 by y minus 2. You will see in the graph that at y equals 2, all slopes equal 0, or at y equals 3, all slopes will be 3/4 per se. If you were not able to get the full grasp of AP Calculus slope field problems, here's a list of released AP Calculus problems in which you can practice slope fields. These can be found at apcentral.collegeboard.com.